Page 9 is titled Interpreting a Line Graph. We kind of talked about what the word interpreting means yesterday. Does anybody remember, or should we start the sentence over again like I didn't say it yesterday? What's interpreting mean? What does a Spanish interpreter or a sign language interpreter help you do? Wait, Caitlin. It translates it. It makes it so whatever that person is saying, the translator or the interpreter is making it so you understand it. It's basically turning the signs into words. And the same can be said with a graph. We can interpret this graph, which means taking this graph or this picture and turning it into words so that you can understand the graph as simple as you could understand words. So that's what interpreting a line graph means. And I'm sure most of you have a really good idea of how to read or interpret a graph. And I'm sure most of you could, and some of you already started, but just stick with me for a few minutes. I'm sure you're good at this already, or at least pretty good at it. I have a system so that you can never, ever get it wrong. And that system is written right here on the top of page 9. So this, instead again taking notes, I did the notes for you, but they're here. Why don't you go ahead and literally label these notes in case you ever forget. I think most of you already knew this stuff, so that's why I didn't make you write it out. But just like always, notes, practice, Regents questions. So when you're doing the Regents questions tonight, I want you to be able to flip back to the notes and check it out if you need help. So here's how to interpret a line graph. Can you guys want me to do this or a PowerPoint? You're good with this? Okay, perfect. So it says interpreting a line graph. When interpreting a line graph, there's like a system, and here it is. Read the bottom variable first. This is your independent variable. Then read the side variable and describe what the line is doing in the center of the line in the center of the graph is doing. Here's what I mean, and I have the example here. So these are examples. All this said is, here's what you do. You read the bottom variable first, B. You guys know, because you've made graphs your entire life, what happens when you go from here to here on the x-axis? What happens to the numbers? They increase, and that's what that line, this arrow here is telling you. So you know you usually start at 0, you count up by something, and this could be 10 there. So the number gets bigger. So how you say this is you start with the bottom variable, the x variable, and you say as B increases. Then you just read the label over here, so A, and then you tell me what the line is doing. So in this case, that's an up arrow. So again, let me say this all together. As B increases, A increases. And I did that example right here. As B increases, A increases. You guys probably already knew that, because I bet if I made this simple graph, I'm just going to make one up right now. Studying, grade. If the graph looked like that, would you have been able to read it? The more you study, so as studying increases, grade increases. Now I know I just made this up because a lot of you know you can do just fine without studying previously. You might need to study this year, just saying. You already know how to read graphs. You just might not have done it in this same format before. So let's try a few practices. So here I want you to write it out. I already got the first one started for you because I said as temperature increases. So I already did this side. So as temperature increases, what's the next step? You read the word pressure. So that's already there. Tell me what this line means. That's an increases. So again, if you follow the system, tell me about the x-axis as temperature, and it will always be increased. So, because this x-axis always goes from small to large. So as temperature increases, read the word, tell me what the line is doing. So let's look at this one. This one looks a little different. So how do I start it? So again, just read the x-axis, it's always increasing. As time increases, then what's the next step? So then you just read the word, temperature. What does temperature do? Read this line. What's that line doing? Stays the same. Easy enough? Should we do one more together, or can you knock all three of those out on your own? Nobody has a thought? Cole, what do you think? Do you think we should do one more together, or let you do the last three on your own? On your own? Do it. Cole made the decision because nobody else would help out here. I was gonna say, I have a feeling a whole bunch of you already did it. That's fine. So give everybody who was actually paying attention a chance to catch up. You're right, you're right. Give me one second, I'll be right with. So they just follow that simple pattern. Read the X, tell me it's increasing, read the Y, describe the line, tell me what it's doing. A little bit. All right, let's wrap this up. And of course, I lost my pen because I walked away. There we are. All right, for the third one down, how do we start that one off? Catherine, you want to tell me the answer to that one? The third one down, this one, density and temperature.
So I could figure out what the density is.
Perfect, I'm glad you spoke up. So the x-axis always increases. So whatever the x-axis is, so you could always just go as blank, which is always x-axis, that always increases. Okay, the x-axis always increases. So for all of them, whatever that is, so temperature, volume, or time, your first sentence should always be whatever the x-axis is increases. So in this case, temperature. So then you want to finish it off. As temperature increases, what happens now what? Okay, so is this a up line or a down line to you? Down, so then we got to switch. That's what you said, isn't it? Sorry, got ahead of myself. Density decreases. So I think what I just did here, that was just like a spur of the moment, like teacher moment to me. I want to put that somewhere, but it looks like we're running out of some space. I have some room right here. Did you guys still have some room right here? So here, that's what I want to do. I want to do as, like an example, as, and put a blank, axis, and I'm gonna write increases. I don't know if I can squeeze it in. I can't. Shoot, why am I struggling? I just put an up arrow and you guys are good with that? Or should I spell it out? Up arrow. As whatever the x-axis increases, then read the y-axis. And then the other blank is whatever the line is doing. So I hope as blank, which is fill in the blank with the x-axis, increases, then you tell me the y-axis, just name it. And then you tell me whatever the line is doing, whether it's an up line, down line, or stays the same line. So it's basically just a fill in the blank sentence. Thanks. You just made me a better teacher. All right, Cassidy, do you have the next one, volume and density? As volume, so volume is the x-axis, it always increases. Then you read the y, that's density. Then you tell me what the line is doing, and that's a down line, so that is a decrease. Just a fill in the blank sentence. Felicia, you got the last one? As time increases, temperature increases. Before we flip over, I actually want to use the bottom here to take one little teeny tiny bit of notes down here. And those are two vocab words that the Regents will sometimes use and sometimes not use, but I want to make sure you've heard these words before. They are, one word is direct relationship, and the other is indirect relationship. Have you heard these words before? Okay, some people have and some people haven't in my last class. So a direct relationship is really referring to when something happens to one thing, it's going to directly affect the other. And what that means is when one variable goes up, so does the other. So if they both increase, or if one increases, they both increase. That's a direct relationship. On the same note, when one goes down, so does the other. Studying is an example of this. The more you study, the higher your grades. Higher studying, higher grades. Indirect, what do you think that is then? Nobody wants to talk? Ooh, what word do you use? They kind of contradict each other. Yeah, that works. So when one variable goes up, the other goes down. So those are two vocab words the Regents might use this year, and you have to be familiar with them. Wait, before we go, so this very first graph we did here, is that a direct or an indirect relationship? Direct, let's label it. Oh, what the heck's going on with that second one? Is that indirect or direct? Or neither, so we're just gonna leave that one blank. How about temperature and density? Indirect, when temperature got hotter, so as temperature increased, density decreased. That's an indirect. How about volume and density is also indirect. Good job, guys. So a few of you at least got it. I'm sure the rest just didn't speak up. Now let's see if you can go the other way. If I give you a sentence, can you make a nice, quick and easy graph? Now, you don't need to put any numbers on the graph, but you do have to label it. So now we know that, because we know the system was as axis increased, y axis, you read the line. So in this case, which one of these is the x-axis? As depth increases, pressure increases, I heard it. So this is gonna be your x. Pressure is gonna be the y, so you do have to label that real quick. Depth, pressure. And it said it increased, so is that an uphill, a downhill, or a flat hill? Uphill. I think you've got 5 to do here. Can you knock those out? Abso-freaking-lutely. In fact, if you just want to put T for right now, you can go with that. Keep it as simple. And temp is a lot easier. I even spelled the word temp. I have to sound it out every single time I write it. Or maybe. You can just leave right together. Oh, we're gonna do the notes first together. Oh, and some practice together. What? So my plan, I guess I could have told, no, it's okay. We're gonna finish at page 10 together. As you may have noticed, your homework's 11 and 12. We're gonna do this top part together, that's notes. We're gonna do several of these questions, as many as we can together, and then I'll let you free on your homework, okay? So not a huge amount of stuff going on today. All right, so let's keep going here. Like Cole said, I'm gonna keep these simple. Cole, give me an example, do the next one for this first one. What goes on the X? Depth. And the Y is then? And which way is this hill? Uphill. Keith, do you mind doing the next one, the altitude and temperature? What goes on the X? Altitude. And that leaves temperature here. And which way does the line go? Down. Jeff, how about you for population and pollution? What goes on the X? Pop. And then that leaves, I can't even, oh yeah, I can, POL. And it goes up. Sarah.
Studying on the X, greater than Y up
And Caitlin. Darn it, Catherine, I know I watched you do this one. I know you have this one right. What goes on the X? time, velocity, and the line. Yep, and actually, that's a good point. You said right in the middle, for that type of graph, if it doesn't really matter where your line is, as long as it's a straight line. You could have it down near the bottom, in the middle, or at the top. It doesn't matter, as long as it's a nice straight line. All right, so as I said, we're gonna flip over to page 11. We've got just a tiny bit of notes there. Rate of change. Without even getting too scientific-y, what do you think rate of change means? Wait, what is it? It's the rate at which something changes, okay? What's rate mean? Like if I ask your heart rate, what? The number of beats per minute. It's how fast your heart rate is beating. So if I ask for your, like, what does rate mean? It just means how fast something's going. So the rate of change, all we're gonna put there is, let me double check what I put in the notes there. That's what I thought. Keep it simple. How fast a change. What did I say? How fast? So I said how fast something changes, sorry. And by something, you can fill in anything. If you're talking about temperature, we could have the temperature change, how fast temperature changes. If you're talking about your growth in the past 5 years, you can talk about the rate of, like, how many inches you grew in the past however many years. It's how fast something changes, and that something can be a whole bunch of different things, which we're going to see in the examples. It's got a spot for the formula for rate of change, and I'm not going to tell it to you, and I already see a bunch of you wiggling towards the answer. Do you have to memorize formulas in this class? What did I say yesterday? No. So all the formulas are in your reference table. What's another word, Carter, for formulas? Equation. Hint, it's on the front page. So I'm gonna let everybody find it on their own first. So everybody's looking in their and yeah, once you find it, how about you write it? Just put it in there. That's how I'll know everybody found it on their own. Front, middle, left. And what is it equal to, guys? Rate of changes? Change divided by time. Perfect. And for a graph, and we'll just copy it from there if you guys can see it. It says graphs allows you to see it allows you to see a relationship very quickly. So it allows you to see that relationship very quickly. And I'm actually going to use the example that's down there at the bottom of the paper to just show you what I mean by, like, looking at a graph to see the relationship really quickly. So we have 4 lines, A, B, C, and D. Which one of these did the change happen the quickest? A. What made you say A? It's the one that increased the fastest. How did you just glance at it really fast? And what's the word in math that you use to talk about that? Do you remember? What kind of slope? Oh, darn it, I just gave you the answer. Slope, do you guys know the word slope?
Yeah.
Yeah, so if these are ski slopes, which ski slope would the change happen the fastest on? Meaning which one does the elevation change the fastest? That's this one. Which one does the change happen? Which one has the slowest rate of change then? D, because it's the most gentle. That's the bunny hill. Now, what's going on there with B? Does it always change the same? No, there's a spot where the change is actually, it doesn't change at all. So the rate of change must change a little bit throughout time there. So let's do a few of these together. I believe I had calculators out on everybody's desk. Looks like a few didn't get them last period. Everybody except for these two up front have a calculator. Okay. So let's just give this a whirl. Every one of these questions for homework, and let's see, there are technically 8 questions for homework. They're all going to use the same rate of change formula. So let's give it a whirl. Let's see if we can do this. Let's do a couple together. The temperature of the water in a container was 60 degrees. 10 minutes later, the water temperature was 35 degrees. What is the rate of change? What is the rate of cooling of the water? Okay, let's go through how you got the answer. So first we need to do the formula, change divided by time. So they didn't tell us how much it changed. They didn't give us a number, but they did say it started at 60 and ended at 35. How'd you get 25? 60 minus 35. So that's how much it changed. 60 degrees minus 35 degrees equals 25 degrees Celsius is how much it changed. How long did it take for that change to happen? 25 degrees Celsius divided by 10 minutes gives us 2.5 degrees Celsius per minute. Ooh, teachable moment that has nothing to do with the question. So if you're working on your homework, stop. I want to look at something on question 2. So this is teachable moment, nothing to do with rate of change right now. So again, everybody pay attention, even if you think you know what you're doing, because I'm teaching right now. That graph in number 2, direct, indirect, or something else? Something else. Because what's an indirect? Or sorry, what's a direct? It would be a straight up line when one variable increases. So in this case, time, temperature would have to go up. They both go up for direct. Indirect, one would go up, the other would go down. So that would be a down line. Yeah, there's sometimes when it's an up line, there's sometimes when it's a down line. This is not direct or indirect. What do you see happening here throughout the day with the temperature? It varies. Any pattern showing there? Do you see a pattern? Like, in fact, you guys have not lived under a rock. It's time of day and temperature. So in the morning, it's kind of cool. So and the AM, it's pretty cool. Then it starts to warm up. Then it starts to cool down. What's the next day's graph going to look like if I kept going? It's going to be the same. It's going to get colder, and then the sun's going to come out. It's going to get warmer. Then it's going to get colder. Then it's going to get warmer. Something that's happening over and over again in a repeating pattern. Have we used a vocab word that describes that activity yet? We did. So we've only done vocab words a couple places in our notes. Why don't you guys flip back until you find the vocab word that describes when something happens in a repeating pattern over and over and over again. That's on page 2, cyclic. And I want to write that right here. Has anybody seen another cyclic graph recently? No, not, not many people, not everybody has gotten this far, but a lot of you have. There's the graph from lab. Up, down, up, down, up, down, up, down, up, down. Is there a pattern to the number of sunspots? There is, yeah, sometimes it starts up low, goes high, goes low, goes high, goes low, goes high, that's cyclic. So we would be able to predict when another day that's going to be, or when another year is, that'll be a high number. All right, so you guys have about 5 minutes, 4 or 5 minutes. I want you to keep going with these questions until the bell rings, or at least until right before the bell rings. Because this will give you a chance to work on your homework and ask Mr. D and I for help with your stuff. If you haven't already written down your homework, do so. Also, remember, we have a short quiz tomorrow right away when you first walk in. 4, oh, you mean right now?
Yeah. Before 12.
Okay, as long as you get this done before tomorrow.